All right, guys, we're going to be working over this practice quiz on the first two sections of Chapter 10. Let's jump right in. All right, we have a sequence right here, and the question is it arithmetic, geometric, or neither? Well, there's a couple of things that we need to know in order to be able to answer this. Arithmetic sequences, we all know that sequences are just a list of numbers, but arithmetic sequences have a common difference. Okay, arithmetic sequences have a common difference. And as for geometric sequences, those have a common ratio. Okay, so again, arithmetic, common difference, and we always use the variable d, and geometric is common ratio, and we always use the variable r to represent that common ratio. Anyway, how do we calculate whether we have a common difference or common ratio? We have to take a number and then subtract the previous number from it. So it's going to be negative 24, take away 48, and then do 48, take away negative 96, and see if you have a common difference. Or you might have a common ratio. Now remember, ratios, they mean fractions. Fractions are really division problems. So all you got to do is take the number and put it over the previous number. So negative 24 over 48, okay? And then positive 48 over negative 96, and see if there's a common difference or common ratio, right? Again, let's check if there's a common difference. How do I do that? I'm going to take this number, negative 24, and I'm going to subtract the previous number from it, right? Subtract the previous number from it. So it's negative 24, take away 48. And the answer is negative 72, okay? So now let's see if that difference, that common difference of negative 72 is actually common. Will it happen when I go 48, take away negative 96? Let's try that. 48, take away negative 96. And as you can see, you're going to end up changing these to plus, and you end up with a huge positive number, which is definitely not negative 72. So there is no common difference. So it's definitely not arithmetic. As you can see, there's a red dot there. That means arithmetic is not the correct answer. Okay, so the question is it geometric or is it neither? Let's check and see if it's geometric. All we got to do is take this number and put it over this one right here. So if I take the negative 24 and put it over the previous number 48, we get a fraction. Now what kind of fraction is this? Well, that reduces down. If you reduce by 24, you'll end up with a negative 1 over 2. So the ratio here is negative 1/2. Now let's see if that's true on the other one. Let's see if that ratio is common. So if I get the 48 and put it over negative 96, will it reduce down to negative 1/2? And the answer is absolutely yes. It reduces down to negative 1/2. So as you can see, they are common. So this is a common ratio. So this means that it is geometric. Now, what if you took the number, subtracted the one before it, and you didn't get a common difference when you took this one and subtracted, and then you tried to do the common ratio, you took this one divided by this one, and it wasn't the same as this one divided by this one, then it would be neither. But in this case, there was a common ratio. That common ratio is negative 1/2, okay? Let's move on to the next question. So on this one, whoops, I didn't cover this one. We know it's one of these answers. It's not none of these are correct. So on this one, we want to take this sequence and find a sub 8. Now, what does a sub 8 mean? It means the 8th term on the list, right? So I hope we remember that the first term is called a sub 1. The second term is a sub 2. Third term is a sub 3. So we have 1, 2, 3 numbers. We need 4, 5, 6, 7, 8. We need the a sub 8th term, okay? So first we need to determine whether this is arithmetic or geometric. Okay, so does it have a common difference or a common ratio? Let's check and see if it has a common difference. If I take the number 6 and then subtract 3 from it, right? 6 take away 3, we're saying that the common difference is 3. Let's see if that difference is common. If I take 3, take away 1.5, that's not going to give us 3. So there is no common difference. So it's definitely not arithmetic. It might be geometric. Okay, so it looks like it's geometric. Let's actually try it. Let's take the 6 and divide by 3. Okay, writing it down, 6 divided by 3, that is the answer 2. Now the question is is 3 divided by 3 halves also 2 in order for it to be a common ratio, right? Because again, this is we're checking to see if it has a common ratio. So let's actually divide 3 divided by 3 halves. Okay, so here it is, 3 divided by 3 halves. Now, it might make more sense to write it horizontally instead of vertically. 3 divided by 3 halves. Now, we know that when you divide by a fraction, you really are multiplying by the reciprocal of that fraction. At least we should know. So we really have 3 times 2/3. And of course, you could put the 3 over 1 and multiply the top with the top, getting 6, and the bottom with the bottom, getting 3. And 6 divided by 3 is also 2. So as you can see, the common ratio is 2, and it is 2, so it is geometric. It is geometric. It's a geometric sequence. Now, they didn't even ask us if it was arithmetic or geometric, but we need to determine that because we need to know how the numbers are changing from here to here to here, all the way to the 8th term, which is what we want. So we know that the common ratio is 2. Now, what does that actually mean? If I take 3 over 2 and multiply it by 2, the 2's will cancel and you'll just have a 3 left over. And then 3 times 2 gives you 6. And then we could continue with this pattern. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. 48 times 2 is 96. 96 times 2 is 192, which means that's your answer right there. 192. Okay, moving on. Another straightforward question: is it arithmetic, which means that it has a common difference? Is it geometric, which means it has a common ratio? Or maybe neither, right? So let's take a number and subtract the previous one from it, okay? And let me do this in red since we're doing the common difference. It's 5, take away 2, that's 3. How about 2 take away -1? 2 take away -1, yep, that's also 3. It looks like it's arithmetic, but we got to make sure it's common in all the terms. So how about -1 take away a -4? Let me write that down. -1 take away a -4. That does change to plus plus, so that does become 3 also. So anyways, yes, there's a common difference of 3, which makes it arithmetic. Okay, I don't even have to test if it's a common ratio because I already found out that there's a common difference, which means it is arithmetic. That's why that's green and all these other ones are red. Moving on. Find the a sub 4 term. That means the 4th term of the following sequence. So don't overthink this. Understand that a sub 1 is your first term. So this is a sub 1. This is a sub 2. This is a sub 3. Guess what? This is a sub 4. I know. Ridiculous, right? The answer is 2. Why? Because, again, let me show you. Hold on a second. Let me actually zoom in here. So we have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So on this one, I'd say state the a sub 4 term. That's this guy right here. That's all you got to do. Just have to understand what a sub 4 actually means. Now, yeah, of course, there's probably like one of the few free questions I'll give you, or simple questions like that. Most of the time I'll ask, what's a sub 8? You got to find the pattern. What's a sub 20? Find the pattern and keep working. But this one's ridiculously easy. The answer is 2. All right, let's move on. All right, we have another sequence here, a list of numbers, and they're asking us if it's arithmetic. That means that is there a common difference between all of the terms, or is it geometric, a common ratio in all of its terms? So let's first begin with arithmetic. Is there a common difference? So 48 take away 24 is 24. But if I go 24 take away 12, that's not 24. So the difference is definitely not common. All right? You go for these easy ones. 2 take away 1, that's 1. But 4 take away 2 is not 1. So it's definitely not arithmetic, okay? Now, when we check for geometric, that's where it gets a little interesting, because we're like, okay, if I take 2 and divide it by 1, what's 2 divided by 1? Oh, that's 2. So maybe the common ratio is 2. How about 48 divided by 24? 48 divided by 24, that's also 2. 24 divided by 12. 24 divided by 12, that's also 2. You're probably thinking geometric, right? But if you pick geometric, it's going to be wrong. Okay, we already know arithmetic's wrong, but geometric is also wrong because the key word is common. All right, it has to be a common ratio. Now, what does common ratio mean? Mean that it exists between all of its terms. And if you focus in on 12 divided by 6, that's also 2, but 6 divided by 4 is not 2. So because of the 4 and 6 right here, that's what messes this whole thing up. It's not geometric either. So is it arithmetic? No. Is it geometric? No. It's neither. It's just a list of numbers. That's a sequence, but it's not arithmetic nor geometric. Moving on. So right here, they're asking us for the a sub 7th term. That means the 7th number on this list. So again, remember the notation. This is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So this is a sub 5. We need 2 more, 6, 7. Now, before we find that a sub 7 term, let's identify whether this is arithmetic or geometric. Is there a common ratio or a common difference? And as you can see, 5 take away 2 is 3. 2 take away a negative 1 is also 3. Negative 1 take away a negative 4 is also 3. Negative 4 take away a negative 7 is also 3. So there's definitely a common difference, 3. Once again, how? When you take a number, divide or subtract the previous one from it. Let me actually write that down. Negative 4, take away the negative 7, that will be 3. So the common difference is 3. Anyway, we know the common difference. What does that mean? That from here to here you actually add 3 because it's a positive 3. Negative 7 plus 3 is negative 4. Negative 4 plus 3 is negative 1. Negative 1 plus 3 is 2. 2 plus 3 is 5. 5 plus 3 will be 8. That'll be a sub 6. And a sub 7, 8 plus 3 will be 11. So the answer is, as you can see right here, 11. Let's move on to the next question. On this next question, we want to find the 9th term of this following sequence. So again, the 9th term. So we have a sub 1, a sub 2, 3, 4. We want 5, 6, 7, 8, 9. Okay, so in order to do this, we need to understand whether it's arithmetic or geometric. Is there a common difference or a common ratio? As you could see, it looks like a common ratio. So if you take the negative 16 and divide it by the previous number, 32, negative 16 divided by positive 32, that will reduce down to negative 1/2. If you take 32 and divide it by the previous negative 64, 32 divided by negative 64, it'll also be negative 1/2. Of course, you could do this on the calculator. If you take negative 64 and divide it by the previous 128, negative 64 divided by 128 on a calculator will also reduce down to negative 0.5 or negative 1/2. So as we could see, the common ratio is negative 1/2. Okay, so what is that telling us? That tells us that from the first term to the second term, you actually multiply 128 times negative 1/2, that'll give you negative 64. Times negative 1/2, that'll give you positive 32. Times negative 1/2, that'll give you negative 16. Times negative 1/2, that'll give you a positive 8. Times negative 1/2 will give you a negative 4. Times negative 1/2, that'll give you a positive 2. Times negative 1/2, that'll give you a negative 1. Times negative 1/2, that'll give you a positive 1/2. So as you could see, our multiple choice options here, there is no 1/2. So that's negative 1/2, that's positive. Okay, so not that one. It looks like down here it says none of these. Let me move this out of the way. And yeah, as you could see, there's a green dot, and that should say none of these. It got cut off, I apologize. But there is no correct answer for the common ratio here. Not for the common ratio, for the a sub 9th term, which should be positive 1/2. So none of them was positive 1/2, so none of these are correct. Let's move on. Number 8, select all the following true statements. Well, arithmetic sequences have a common ratio. False. Arithmetic sequences have a common difference. So yeah, that's red because it's wrong. Again, they don't have a common ratio. Actually, I misspelled that. It should just be ratio. But it has a common difference. So common difference. That would make it true, okay? But because it says ratio, it's false. Right here we have negative 9, 1, negative 11, 21. This sequence is neither geometric nor arithmetic. Well, is there a common difference? If we go 21, take away a negative 11, that's going to be a positive 32. And of course, you can do that on the calculator. And if you do negative 11, take away 1, that's not positive 32. So there is no common difference, which means it's not arithmetic. Now, how about geometric? If I put 21 divided by negative 11, will it be the same thing as 1 divided by negative 9 or negative 11 divided by positive 1? No, it's not. So it is definitely not arithmetic, not geometric. That is a true statement because it says it's neither geometric nor arithmetic. So that's a true statement. Does this sequence have the common ratio of 1/2? Well, 24 divided by 12 is 2. 12 divided by 6 is 2. 6 divided by 3 is 2. So the common ratio is 2, not 1/2. Okay? Again, take the number, and if you're looking for the common ratio, divide it by the previous number. 24 divided by 12 is 2. 12 divided by 6 is 2. 6 divided by 3 is 2. So this one has a common ratio of 2. And it says has a common ratio of 1/2. That makes it false. So as you can see, red dot right there, it's false. Moving on. Does this have a common difference of 4? Well, 1 take away a negative 3 is positive 4. Negative 3 take away a negative 7. That's really negative 3 plus 7. That is a positive 4. So this one is true because it does have a common difference of 4. That's arithmetic. A sub 1 will always be the first number on your sequence. That's absolutely right. A sub 1 is always the first number on your sequence. Let's move on to the next question. We have a sequence up here. It says select all the following true statements about this sequence. This is an arithmetic sequence with a common difference of 4. Well, if I go negative 6, take away a negative 2, that will not give us 4. If I go negative 2, take away 2, that'll give us a negative 4, not a positive 4. And 2 take away 6 is a negative 4, not a positive 4. So this is definitely false because up here, the difference, the common difference is negative 4. Okay? And over here it says that it's positive 4, so that's false. No way. Okay, moving on to this next one. This is a geometric sequence with a common difference of negative 4. Well, we already know it's a common difference of negative 4, but if it has a common difference, it's arithmetic, not geometric. So right here, what makes this false is the word geometric, okay? That should have been arithmetic. This is what's messing it up. That's what makes it a false statement. Yes, it does have a common difference of negative 4, but that should read arithmetic. Moving on, a sub 5 equals 10. I don't know. This is my first term, second term, third term, fourth term, and we know that it has a common difference of negative 4. What does that mean? From the first one to the second one, 6 take away 4 is 2. 2 take away 4 is negative 2. Negative 2 take away 4 is negative 6. Negative 6 take away 4 is negative 10. Negative 10 take away 4 is negative 14, and so on and so on. You could keep going. Again, we want the fifth term, so we have 1, 2, 3, 4, 5. So negative 10 is the correct answer. That's a positive 10. That is incorrect. How about this? A sub 2 is 2. Well, yeah, that's given to you. A sub 2 is simply the second number on the list. That is the number 2. That is a true statement. And of course, if that's true, that means that none of these are true is a false statement. This is the only true statement on this question. So on this question, we want to find the fifth term. So keep in mind that your first term, a sub 1, is right here. Second term, a sub 2, is right there. A sub 3, we need a sub 4, which is right here, and a sub 5, which is right there. Let's first find out whether we have a common difference or common ratio. Obviously, if we were to take 1/3, take away negative 1/9, it's not going to be the same thing as negative 1/9, take away 1 over 27. So it might be a common ratio. Let's check. If I take 1/3 and divide it by the previous number, divide it by negative 1/9, okay? That will be 1/3 times the reciprocal, negative 9 over 1, which when you multiply it, negative 9 over 3 would be your answer, which is negative 3. So it looks like the common ratio is negative 3. But let's double check that by going to negative 1/9 and dividing by 1 over 27. So negative 1/9 dividing by 1 over 27. Again, we're going to rewrite it, negative 1/9 times 27 over 1. And when we multiply it through, the top with the top, that'll be negative 27. On the bottom, 9 times 1 is 9, so you get negative 27 ninths. And negative 27 divided by 9 is negative 3. As you can see, the common ratio is negative 3. Okay, so now that we know that, what does that mean? That means if I take 1 over 27 and multiply by negative 3, that'll become negative 1/9. You go negative 1/9 times negative 3, that'll become positive 1/3. Then positive 1/3 times negative 3, that'll give us a negative 1. And then negative 1 times negative 3, that'll give us a positive 3. So the answer is positive 3. Don't put the common ratio as your answer. It's not asking for the common ratio. It's asking for the fifth term, okay? First term, second, third, fourth, fifth. And again, the common ratio tells you how you get from one term to another, right? 1/27 times 3 is 3/27, which reduce, actually times negative 3. 1/27 times negative 3 is negative 3/27, which reduces down to negative 1/9. Negative 1/9 times negative 3 is positive 3/9, which reduces down to 1/3. 1/3 times negative 3 becomes negative 3/3, which reduces down to negative 1. And then negative 1 times negative 3 is positive 3. So your answer is positive 3. Type in positive 3. Question number 11. I cut off the multiple choice answers, but what we need to do on this question, what we need to know is, what is the a sub nth rule for an arithmetic sequence? So the a sub nth rule for an arithmetic sequence, remember on an arithmetic we have a common difference. And how does the arithmetic sequence begin? Well, it begins with your first term, your a sub 1 term. That's what a sub 1 means. It means your first term. And of course, when there's a common difference, you're pretty much going to be adding that common difference, right? So if you have like 5, 7, 9, what's a common difference? It's 2, because 5 plus 2 is 7, 7 plus 2 is 9. So you're always adding the common difference. And again, the logic is you begin with your first number, that means your first number, and you're going to be adding a common difference. But that's why there's a plus right here. Now, we do have parentheses, and inside of the parentheses is where it gets a little weird. This is where you have to memorize. It's n minus 1, and then out here you have times the common difference d, okay? So this is your a sub nth rule for any arithmetic sequence. Again, on the arithmetic sequence, on any sequence, it begins with a sub 1, it's your first number. And on arithmetic, you are adding parenthesis n minus 1 times your common difference d, okay? So let's go back to that example that I just said, 5, 7, 9, okay? Well, what's the common difference? The common difference is 2. And how do we get from here to here? Well, you add 2. How did we actually find the common difference? You took 9 and subtracted the previous number from it. 9 take away 7 is 2, or 7 take away 5 is 2. Anyways, the common difference is 2, okay? So if I said, give the a sub nth rule for this arithmetic sequence, the a sub 1 would be a5, and then you have plus, and then parenthesis, n minus 1. Now, n is talking about the number of numbers that are on your list. So we know that most of these sequences are infinite, not finite, have a dot, dot, dot. So we don't know what number it actually gets to. And that's going to be the variable that we use to find whatever term we want. And we do have a minus 1, and we have the common difference, which is 2. And let's simplify this a sub nth rule by distributing. That'll be 2n minus 2 with a plus 5 out here in the front. So the a sub nth rule is 2n plus 3. When I add 5, when I combine like terms, 5 take away 2 is 3. So this right here, my friends, is the machine that produces this list specifically. I'm going off on a tangent here. All you needed to know for this question is that this is the rule, but I actually did an example. I created this arithmetic sequence 5, 7, 9. It's just odd numbers starting with the number 5. And this is the machine that produces that. In other words, this is a sub 1. So a sub 1, n would be 1. If I'm talking about the first term, n would be 1. You'd put a 1 right here. 2 times 1 is 2, plus 3 is that first term, 5. Let's say you wanted the third term on this list, which is actually 9. So if you want the 9, it's going to be a sub 3. because that's what 9 is. It's the third term on the list, a sub 3. So if that n is really a 3, you have to put a 3 right here. 2 times 3 is 6. 6 plus 3 is 9. If you want the second term on the list, the 7, that would be a sub 2. That's a notation for the second term. Plug in 2 right there. 2 times 2 is 4, plus 3 is that second term, 7. I hope this makes sense, and I'm sorry about the excess explanation right there. This is the answer. A sub n equals a sub 1 plus n minus 1 times the common difference, d. Find a sub 21. Dang. All right, well, let's first understand that this is an arithmetic sequence because it does have a common difference. 29 take away 22, that's 7. 22 take away 15, that's 7. 15 take away 8, that's 7. So the common difference is 7. And just to verify, 8 plus 7 is 15, plus 7 is 22, plus 7 is 29. So if I wanted to, I could go, this is barely the 1, 2, 3, this is barely the fourth term, so I could go plus 7, 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 until I get to the 21st term, which I don't recommend because for sure you're going to make a mistake. So what I do recommend is finding that d and then using the a sub nth rule of arithmetic sequences to be able to find the 21st term. So what is the a sub nth rule? It's a sub 1, the first term, which is going to be 8, plus parenthesis n minus 1 times the common difference d, and the common difference is 7. So let's take the 8, the a sub 1, and put it right here. And of course we have the plus parenthesis n minus 1 times the common difference, and we said the common difference is 7, so put a 7 over here. We are multiplying by it. So what do? We distribute first. So we're going to have 7 times n, that's 7n. 7 times negative 1, that's negative 7. Bring down the plus, bring down the 8. You have 3 terms. You could combine the first term and the last term. 8 take away 7 is positive 1, right? So what we really have here is the 7 left over, 7n, with a positive 1. Now this is the simplified a sub nth rule that produces this list. Again, just to verify, if I want the third term, which we know is 22, if I want the third term, all I have to do is think a sub 3, which means I plug in a 3 right here. 7 times 3 is 21, plus 1 is that third number, 22. So they are not asking for the a sub nth rule, but we do need it. We want to find a sub 21. So to find a sub 21, what does that really mean? You see that the n got replaced with the 21. That's what I'm going to do. I'm going to replace this n with the 21. So what I really have is, instead of 7 times n, I have 7 times 21, and then plus 1. Now, with the calculator, 7 times 21, it equals 147, plus 1 more, that'll be 148. Wow, 148. So let's check our answer. There it is. Correct answer is 148. So if I did go 8 plus 7, get 15, plus 7, plus 7, plus 7, all the way to the 21st number, that 21st number would be 148. Moving on. We have another same type of question. Find a sub 13. Let's first find the a sub nth rule that actually produces this arithmetic sequence. Now, why do I say arithmetic? Because I could already see that there's a common difference here. If I go 47, take away 54, or if I go 54, take away 61, or 61, take away 68, we will see that we get negative 7 on all of those. Negative 7 on all of those. Negative 7, negative 7, negative 7. I just did them on a calculator, so that is true right there. So we know for sure that the common difference is negative 7. Okay, now let's think about the a sub nth rule for an arithmetic sequence. And I want to write it instead of I'm going to show you how I think when I write it. A sub n equals, I know that any sequence begins with the first term, a sub 1. Now, I know arithmetic, that common difference, it's being added as I go. If I go 68 plus negative 7, it'll give me 61. Plus negative 7, it'll give me 54. Plus negative 7. So I do have a plus sign right here. Then the parentheses, then you have the n minus 1 times the common difference d out here. Okay, so that's the a sub nth rule that you need to have memorized. A sub 1 is 68, so let's put a 68 right here. We do have a plus parenthesis n minus 1 times that common difference, which is negative 7. Okay, now I would put it in parentheses so you don't mistaken it to be a minus 7. It's actually a negative 7, right? So we're going to distribute. We have negative 7 times n, that's negative 7n. Negative 7 times negative 1 is a positive 7. We have the 68 in the front. We could combine the 68 with 7. That'll give us the final a sub nth rule of negative 7n plus 75. So now that we have this a sub nth rule, now we could actually find a sub 13. Okay, a sub 13. And how am I going to do that? Well, I have negative 7, but instead of n, I'm going to put that 13 and then plus 75. And let's do the math, and it'll give us the 13th term on the list. So on a calculator, if I go 7 times 13, it'll give me 91, and it's negative 91. And if you go negative 91 plus 75, that'll give us a negative 16 on a calculator, of course. So if you kept going by subtracting 7, or plus negative 7, plus negative 7, plus negative 7, it'd be 40, it'd be 33, and you keep subtracting 7 as you go down, and the 13th term will be the answer, negative 16, the number negative 16. So there's the answer, negative 16. Let's move on to the next question. On this particular question, they want us to find the 6th term. So it might not be that great of an idea to do the whole a sub nth rule just to find the 6th term, because after all, I already have a sub 1, a sub 2, a sub 3, a sub 4. All we need is a sub 5 and then a sub 6. So we need this number and that number, and we will have the correct answer. So let's find out what the common difference is. If I go 15, take away 38, 15, take away 38, and I could also do 38, take away 61, right? The 38 take away the 61, or the 61 take away the 84. 61 take away 84. On all of these with the calculator, 15 take away 38, the answer is negative 23. This one on the calculator is also negative 23, and this one on a calculator is also negative 23. So you could see that the common difference is negative 23. Okay, so instead of doing the a sub nth rule, instead of using it, what we could do is, since you're only a couple of spaces away, let's just plug in or understand that you're subtracting 23 on each term, right? 84 take away 23 is 61. 61 take away 23 is 38. 38 take away 23 is 15. 15 take away 23 on a calculator is negative 8. So I have negative 8 right here. And the last one, negative 8 take away 23, again on a calculator, is negative 31. So that is your answer right there, negative 31. Now, of course, you could have taken the 84 and plugged it right there, and then you'd have the plus n minus 1 times the common difference, negative 23. And you could distribute and you could combine like terms, and then you'd have the a sub nth rule, and then you could plug in the number 6, and you do all that crazy work to get that answer, negative 31. But it's a lot easier because they're asking only for the 6th term, and you already have 4 right here. You're only 2 spaces away. Just use that common difference of subtracting 23, subtracting 23, subtracting 23, subtract 23, you get this, subtract 23, you get that. That's your 6th term. There's your answer. Moving on. So on this one, a sub n equals a sub 1, your first term, plus n minus 1 times the common difference, d. That is true. That's the a sub nth rule for arithmetic sequences. It says it's a rule for geometric. That's incorrect. Okay, so this is definitely wrong. So as you can see, there's a red dot right there. This is a summation formula. The question is this the correct summation formula for any arithmetic series? And it's wrong. Right? First of all, there should be an n out here in the front, and there should be a plus sign between your first term and your last term, okay? So that's definitely wrong. Okay, moving on to this one. It looks complicated. A sub 2 is negative 5, a sub 1 is negative 7 of an arithmetic. They're telling you there's an arithmetic sequence. You don't see the list, but it is arithmetic, and they are giving you your first term and your second term. And it says, knowing that it's arithmetic and knowing your first term and second term, can we conclude that the common difference is 2? The answer is yes. If you just write down what they're telling you, a sub 1 is negative 7. Your first number is negative 7. What's your second number? Your second number is negative 5. Okay. And we know that it goes forever. And we know that it's arithmetic. We know there's a common difference. What is that common difference? If you just simply take this number, -5, subtract the previous number from it, subtract the previous number, -7, from it, what will you get? Plus plus, you'll get +2. So the common difference really is +2. That's what it's saying. This is definitely a true statement. Last but not least, an arithmetic series is simply a list of numbers with a common difference d. That's false. An arithmetic sequence is a list of numbers with a common difference d. A series is when you're adding them all up, when you're taking an arithmetic sequence and adding up all those numbers. So it's a summation. That's false. It's not just a, whoops, sorry. For some reason I can't remove this, so yeah, that's a red dot right there. That's false. An arithmetic series is when you're adding up. It's not just a list of numbers, so that's false. Okay, so this is the only true one. Let's move on. Find the sum of the arithmetic series. Well, in order for us to find this sum, we need the summation formula. Hopefully you have that memorized already. Summation formula is S sub n equals n times parenthesis a sub 1 plus a sub n divided by 2. Instead of me just reading that, let me explain it. The S means that you're going to add them all up. The sum of however many numbers are on your list. You might have 20 numbers on your list. You might have 100 numbers on your list. The thing is, I don't know how many numbers are on this list. It's not like there's 1, 2, 3, 4 numbers. No. There's a bunch of numbers missing, right? You have it looks like there's a common difference of 2. So you have +8, +10, +12, +14, say all the way to 100. Okay, so let's take what we know. And what do we know? Well, we know the first term, we know the last term, so we know this one and that one, but we don't know how many numbers there are in the whole list that we want to add up. So that's a problem in itself. So before jumping to the summation notation, let's actually start with the a sub nth rule. The a sub nth rule of an arithmetic sequence is a sub 1, which in this case is 2, plus parenthesis n minus 1 times that common difference d, which in this case is also 2. Okay, kind of confusing. A sub 1 is your first term, which is 2. And we also have the common difference, which is 2. So the common difference is 2, and the a sub 1 term is 2. So we're going to put that common difference right here, where the d is at. N minus 1 plus a sub 1, that's the first term on our list, which is in this case 2 also. And let's simplify this to actually get the a sub nth rule. The a sub nth rule is distributing. We'll have 2 minus, or a -2, and with a 2n in front, and we have the plus 2 that comes down. And let's combine the first term and the last term. That cancels out, which just leaves us a sub n equaling 2n. Okay, so if I want the first number on my list, all I have to do is think a sub 1, that's the first number on the list, plug in a 1, 2 times 1 is 2. If I want my third number, if I wanted the third number, a sub 3, plug in 3, 2 times 3, that gives me 6. So I want to solve for what n actually is. How many numbers are there, right? How many numbers are there? Well, this is the last number. Whatever number that may be, that's what a sub n means. That's the last number, right, on the list. Even on the summation formula, first number plus last number. So the last number is 100. So a sub n is really 100. So if we plug in what we know, we'll be able to find out what we don't know. A sub n is 100, and if you have it equal to 2n, and you simply divide by 2 and divide by 2, you'll know that n equals 50. What does that mean? That there are 50 numbers in this list from 2 to 100. This is not an infinite series, it's a finite series. From 2 to 100, there's 50 numbers. How did I figure that out? By plugging everything in that I know to find out what I don't know. Now I know that n equals 50. Okay, so there's 50 numbers. 1, 2, 3, and there's a heck of a lot more numbers in here. 46 more numbers, and then this is the 50th number. Okay, so now we could jump to the summation formula, because now we know what n is. The summation of the 50 numbers that we don't even see will be equal to n, which happens to be 50, times a fraction. A sub 1 is your first term 2 plus a sub n, which we know a sub n is the last term, 100, all divided by 2. So this is the math that we have to do. I would always begin with parentheses. On the inside, I would add 102 divided by 2, and that'll be 51. So the summation of the first, or of the 50 numbers that we don't even see, will be 50 times 102 divided by 2. That's 51. Okay, and 51 times 50 will be the final answer. 2,550. 2,550 is the final answer for the summation of the first 50 terms. Check our answer over here. There it is, 2,550. Last question on this video. They give you your first term. They give you the common difference of all your numbers in that sequence. They're telling you it's arithmetic, and they want you to find the 21st number of the sequence. So they give you that your first number is 14, and there's a common difference of 9, which means 14 plus 9 is 23. 23 plus 9 is 32. 32 plus 9 is 41. And you could keep going till you get to the 21st term, but that would be a lot of pain, right? So what I'm going to do instead of that is use my a sub nth rule. A sub n equals a sub 1 plus parenthesis n minus 1 close parenthesis times d. And I'm going to plug in the a sub 1 term, which is 14, right in there. N minus 1. And I'm also going to plug in the d value, which we know is 9, right? And then I'm going to simplify this by distributing and combining like terms. 9 times n is 9n. 9 times negative 1 is negative 9. Bring down the plus 14. Combine the 14, take away 9, and that'll give you a 5. So you really have 9n with a positive 5. And this is your a sub nth rule. This is the rule, this is the machine that produces the list that we have up here, right? So if I wanted the first term, if I plug in a 1, 9 times 1 is 9, plus 5 is that first number, 14. If I wanted the fourth term, I'd plug in a 4 right there. 9 times 4 is 36, plus 5 will give me that fourth term, 41. So obviously they want the 21st term. So what am I going to be plugging in? 21. So I'm plugging in a 21 in place of n. So that will be 9 times 21 plus 5. And of course, you can do this work with the calculator. 9 times 21 equals 189. And then plus 5 will give you 194. So that's your final answer, 194. I hope we understand it. Good luck on the quiz.